eminent guests who have gathered here for hosting the event in AI and autism space. Reva Academy for Corporate Excellence, Reva University, with support of Usha Rangreju, Chief Data Scientist, EXA Protocol, has initiated this award to create awareness of how artificial intelligence can benefit in early detection of autism and support community. We have conducted series of events with respect to autism awareness, and this stage is just the beginning to explore how technology can be benefit to autism community as a whole. Our main motto is to collaborate medical, technology, and society. We are together on this journey, and together we will surely win. Our special thanks to our swag sponsors, Swissray and Terralogic, for coming together to support and encourage data scientists, students, and experts in AI/ML to work for the betterment of autistic children through Kaggle competition. Now over to Dr. Sheenu Abhi, Director, Reva Academy for Corporate Excellence, Reva University, to dive deep through this most awaited event. Over to you, Dr. Sheenu.
Thank you, Kinjal. Am I audible? Okay.
Yes.
Good evening, everyone. It's a pleasure to welcome you all to this evening where we would want to introduce domain experts coming together with AI experts and discussing one of the most pertinent problems which is affecting our society. At Reva Academy for Corporate Excellence, Reva University, we have been working on learning analytics for some time now. One of the areas of interest for us is to bring emerging technologies like AI to help specially abled learners. We recognize that 1 out of 6 of us are neurodivergent, meaning that we function in a very different way than considered as standard. Various neurodivergent conditions like autism, dyslexia, dysgraphia, dyspraxia, Tourette syndrome, ADHD, all have been considered as neurodivergent. Today, there are many technologies and solutions are helping neurodivergent individuals to improve their quality of life. Say, AI-driven hiring platforms, socially sensitive robots, smart glasses for emotion detection, speech recognition apps, eye tracking, virtual and augmented reality-enabled learning solutions, and more. While our AI engineers at Reva University are piloting a few use cases, we recognize that it's very important to bring domain experts and the end users into this dialogue. They bring much more inclusive solutions as per the need of the most important and ultimate stakeholders, which are parents and their kids. We are so glad that we have 2 eminent neurologists to help us understand the state-of-the-art medical facilities available today, not just in India, but around the globe for early detection of neurodiversity and autism. We also feel that there is so much stigma around neurodiversity in our society. As a university, it is our duty to create awareness and help sensitize everyone that early detection can be of very, very important step so that appropriate technologies can be of great help. In today's session, our endeavor is to bring both the experts into one forum, Dr. Ravi and Dr. Lokesh, who have been renowned practicing neurologists and have been very vocal on these medical solutions. Dr. J.B. Simha and Usha Rangaraj are renowned AI specialists championing this noble cause. We saw great traction when we launched our Kaggle competition with an open data set on autism spectrum disorder screening, which had behavioral-based survey results from more than 700 people and their demographic variables. And we are glad that our toppers could predict autism with almost 90% accuracy based on those variables. While we applaud all the 130 plus Kagglers who submitted their scores, out of which we have selected 6 of them who are top scorers. So today, our event is going to be divided into 3 parts. First part, we will listen to the current and future status of autism detection from our expert neurologists, Dr. Ravi and Dr. Lokesh. In the second part, we will listen to Dr. Simha and Usha Rangaraj about how AI can help in early detection, which can help medical researchers. Third, we will bring all the top scorers and provide them the swags virtually. Of course, the swags are reaching you in person to your houses. And we request all of you to keep an open mind during this session. Please share your questions in the chat window, and we'll take up a few questions towards the end. I hope we will see you till the end of this program. It's going to be a very, very insightful session, bringing the best of both the worlds together. Now, may I request Pavitra Suresh from our team to introduce the speakers?
Thank you so much, Dr. Sheenu. Good evening, everyone. This is Pavitra Suresh. Am I audible? Good evening, everyone. This is Pavitra Suresh from Reva Academy for Corporate Excellence, Reva University. A very warm welcome to all. Tonight, this task of introducing our guests and speakers is a great honor for me. I feel elated to introduce Dr. Lokesh, who is a consultant neurologist. He heads the Department of Neurology at Aster CMI Hospital, Bengaluru, and is a renowned expert with 2 decades of experience. He is trained in cerebrovascular sonography from National University Hospital, Singapore, and the University of Alabama, USA. He is a globally renowned speaker in neurosonography. Happy to have you on board, sir.
Thank you.
The second guest for tonight is Dr. C.P. Ravikumar, who is a consultant pediatric neurologist. He is a renowned specialist in the field of pediatric neurology at Aster CMI Hospital, Bengaluru. He has led and established Aster UKIDS Child Development Center at Aster CMI Hospital in association with Sukhumvit Trust. It has been known for offering the highest quality care in a child-friendly environment to promote special care for children to resume back to normal functional potential. Dr. Ravi Kumar is also the founder of Brainchild Trust to help children affected with neurological disorders and support their families. May I request Dr. Lokesh and Dr. Ravi Kumar to come on video mode and talk about early detection of autism.
Hi, thank you for the introduction, Pavitra.
Just a second, we have, I think it's visible. It's visible. Can you put Dr. Ravi's profile once more? Yeah, full screen, please. Yes. And Dr. Lokesh, yes.
Okay, we are audible, right? Hi, good evening. Can you hear us?
Yes.
Okay. Can we go ahead and start?
Dr. Ravi, can you see the slide deck, the presentation? Okay.
Yes.
So you are on Dr. Ravi.
Okay. Will you be moving the slides? Okay, good evening, everyone, and thank you for joining today evening. So let's, on this time, me and Dr. Lokesh are going to split our talk on this topic. I'm going to speak about autism, what it is from the medical content, and Dr. Lokesh will connect the medical part to your field of work, that is artificial intelligence. Autism is still an underdog. It's been going on for many years, but unfortunately, it's always undetected. And many of these children in the past were labeled as mentally retarded and forgotten. But we know autism is a very widely prevalent and also has a very wide spectrum, which makes it more challenging for us to identify and diagnose and also to start treatment. The global map or the American map, which you see on the right side of the screen, it is the latest data from Center for Disease Control from the United States. It gives you an idea on how the numbers are increasing year on year. And on the left side, you have certain data that is from 2011 from Indian population. Generally, what we know is 10% of the children will have neurodisability. Means 1 in every 10 child will have some form of neurodisability. This can be physical, this can be mental, this can be social, this can be emotional. So there is some kind of disability in children. With respect to autism, it is said on an average there are 8 new children being added per day with the label of autism. In addition, there is a huge spectrum of those children who do not fit into this category of autism, but will have certain features of autism and few other things. But also what we need to remember in India is the data collection is not the best. So if you think it is 8, probably it is 80 per day. And we will never be able to get an accurate number anywhere in the world, especially in an Indian setting where the population is too diverse. The rate of autism is definitely increasing. There is a big debate going on: is autism, is there an epidemic, or is it just that more and more people are aware, and thanks to technology and thanks to the internet, are people able to pick up the signs and seek help? And also medically, if you have to just give a context, when I studied in medical school, we hardly read about autism, and we had rarely identified a child with autism. Not that they did not exist. I'm pretty sure they existed, but we did not have the skills. But now you have more and more doctors who are trained, who are aware, and who can pick up the signs of autism. In addition, the technology, access to the science from the, say, for example, from Dr. Google, many parents can pick up on their own. Next slide, please. That probably explains how the numbers are increasing. See, what is autism spectrum disorder? See, few things we generally, when we speak or even during the talk, we may say autism, but we mean ASD, that is autism spectrum disorder. So it is a huge kind of range of clinical features or the problems in the child, which varies from child to child, and it is very difficult to put them under one single umbrella. It is a developmental disability caused by the differences in how the brain functions. So it is more of social and communication. I'll come to that in the next slide. So if you look at the DSM criteria, that is from the American Psychiatry Association, there's a broad umbrella called pervasive developmental disorders. Many times we just shorten it to PDD. Within that, you have 3 broad headings. One is the autism spectrum disorder or autism, and within that you have the classical autistic disorder. Then you have the high functioning part of autism, what we call Asperger's syndrome. Once again, there is a debate whether autism and Asperger are separate or is it a part of the continuum. In between, you have what we call PDD NOS. With PDD is pervasive developmental disorder. NOS is not otherwise specified. Basically, they do not fall into the basket of either Asperger's or neither to the autism, but they have certain features of both. So they don't tick all the boxes, but they still fall under the broader category of autism spectrum disorder. In addition, Rett's disorder is a kind of genetic issue where children will have many of these autistic features, but here we call it Rett syndrome, and it's different from autism because the features are part of the underlying genetic defect. And finally, you have the childhood disintegrated disorder, which is very diverse, which borders between neurology and the psychiatric manifestation. The next slide, please. So once again, as I emphasized here, just highlighting you, Asperger's syndrome, autism, and pervasive developmental disorder, not otherwise specified. Next slide, please. So criteria, there are many criteria, but as we know, the gold standard is the DSM criteria, currently DSM-5. It gives you 4 different sections under which you fit a child or find out what problems are there. So broadly, what I can say is the first category is social communication. For example, there is a lack of social reciprocity. Simple. When you look at the child or when you look at an individual, you smile, spontaneously you smile back. That doesn't happen in a children with autism. Secondly, there is no interaction. It is said the word autism comes from a Greek word called autos, means the child is in his own world. He's not interacting or is not engaging with anybody around. The next section is talking about repetitive behaviors. There's something called stereotypic behaviors, like children spinning, switching on and off light, where they get this kinds of sensory stimulation. Then you have very rigid kind of activities. Say, for example, a child needs things to be kept at a specific place. The moment it moves an inch away, they get upset, and it causes a lot of behavioral manifestation. The third one is what we call the classification is more about how when do you diagnose. And the fourth part is limiting the everyday function. When we look at this autistic criteria, if you look at the book, and this is something which we find challenging with parents. Many times parents have already read about autism, and they sometimes challenge us saying it doesn't fit into all of these features. I've read about autism. These are the things he has, and he doesn't have these features, which is true. If you look at all those characters of autism or autistic spectrum disorder, if you look at yourself or look at if I look at myself, there are certain criteria or certain things which matches with us. But what's important is it does not impair in day-to-day functioning. That is one of the important criteria. One of the common scenarios you might all have noticed is you may see some of your colleague or one of your colleague who comes to the office. As soon as he walks in, it's like a party atmosphere. Everybody knows this guy's here. You may have another colleague who comes here, sits quietly, is there, and nobody even is aware that he's already there, quiet. But it does not impair their interaction or work with other colleagues. It is just a personality. But when it starts impairing, when the person cannot interact, cannot engage, that is when it fits into the criteria for ASD. So it is important these behavior patterns impairing everyday functioning. Next slide, please. Now, how do we diagnose the tools? See, one is when we see children in the clinic, it is based on first is history, at the same time what we observe in the child, their interaction, how do they make eye contact, do they reciprocate, do they smile, are they aware of the people surrounding, what kind of activity, all these things are there. Many times we get the clue, and sometimes as soon as they walk in, within a minute we know this child is autistic. But still, that is very subjective, and we have a lot of tools which gives a criteria on which we can make an objective measurements. There are certain tools which we classify into screening and diagnosis. As you know, screening tools have a very high sensitivity but low specificity, meaning we pick up even those who are not clearly autistic. With the agenda, they undergo diagnostic evaluation so that we can confirm for sure that they are autistic. So screening test will have a lot of false positives, whereas a diagnostic will have very low false negatives. So the commonest criteria or the screening tool which we use called MChat, which is easily available on the internet. Many parents access and they score themselves, and even any doctors can look into it. It is freely available. But what is important to remember is, in spite of this being a very high sensitive tool, it has a very low pickup rate even with this. The reason being subjective. Many parents, when they score better when compared to what the child is. The diagnostic tool, the ADOS, is quite an expensive tool which we often don't use in India because it needs a lot of training and investment. But the best one is the AIMS modified inclin. This criteria is based for Indian population. There is another one scale called Indian Scale for Assessment of Autism. CAS is once again from the West, and it is very commonly used. So these tools help us to screen and diagnose. So this is the medical part. So now I'll request Dr. Lokesh. He will speak about what we can do from an AI perspective. How do we adapt?
Thanks, Dr. Ravi. So that's an overview about what is autism and autistic spectrum disorder. Yes, having come from a background of clinical side, and in the last 3 years, I'm into data science and ML. So now, how do we transition? So basically, when we talk about machine learning or developing machine learning algorithms, you have supervised, unsupervised. So now, if you have to pick up anything like a screening tool, so one is to use a tabular column, like you have this MTouch score where you have a very clear-cut tabular data sets. So you can use one of the traditional machine learning algorithms to, get an accuracy of based upon different machine learning algorithms that you work on. But what about video and audio analytics? That means in the real situation, how a doctor is looking at a patient, right? We are not just looking at a scale, is something that we are going to, pick up later. But the first thing that when we diagnose is looking at the child, looking at their behavior, looking at their interaction, speaking to that. So that's where the thing comes about video and audio analytics. These are the two things. And now, with the deep learning, with the neural networks, we can definitely work on these particular tools. But important thing is how do you design these kind of studies for those who are in this audience who are listening to this. When it comes to healthcare data sets, a couple of things that we need to keep in mind. Data privacy is a very important factor that has to be considered. And number two is how do we design the study, right? So when we say they're all are criteria, when you're criteria in the sense they are not like a diagnostic 100% tool. Like for example, in a lab investigation, if a person has blood sugars, you go to the lab, you get a particular result, and then okay, you say that okay, the blood sugars are high or low. But here, when it comes to the neurobehavioral disorders or predominantly neurological conditions or majority of psychiatric conditions, it's all about criteria. It's all about a set of criteria, a set of syndrome complex, a symptom complex that makes up a particular diagnosis. So one is working on the DSM criteria or MCHAT, where you have those people who just tick there, and then afterwards, one person labels that okay, this is an autism, this is not an autism, and then finally you try to develop an accuracy score. That is one aspect of it. But second aspect of it is trying to work on the video and audio analytics, where that's where the live interaction happens. So that's one of the things that we plan to work on, and that would be more appropriate in diagnosis. But a lot of challenges are there. But that's the way that we can go about. We need to collect a huge amount of data, and then we need to label basically what is autism or what is a normal thing. And then in adults, you can give a task and the adult can perform a task. That will be easier. But in a pediatric, there's a challenges there. So there should be a parent who should be able to give that particular task and internally record it and then probably upload. Something like that we need to work on. I think with that, we just we summarize basically what is autism and how the doctors can diagnose this. And early diagnosis is important because a lot of treatment can be planned, and then a lot of strategies can be developed for treatment. And the data science perspective, like how do we develop a tool for early diagnosis so that we can pick up these kids at a very early stage so that the treatment can be started much early, right? Thank you.
Only one point I would like to add what Dr. Lokesh said. For people who are there who are looking at how to build machine learning or artificial intelligence, the buzzword we use in neurorehabilitation is early diagnosis or early intervention. The sooner you diagnose, the better the outcome. Currently, the average age when children with autism get diagnosed is between 18 to 24 months, means the second half of the second year of life. If we can pick it up sooner, then probably we'll be able to get very good results. Because in the long term, these children become a bit of, depending on obviously the underlying problem, they can become a burden to the family and also the society. So if we pick these children early, we can make sure that they are contributors to the society from a longer perspective. Thank you. Hello?
Yes, doctor.
Thank you.
Yeah, you can continue, please. Thank you.
I think we are done, sir. We are done. Any questions or anything else we are happy to take, or we'll wait for the program as per your schedule.
Yeah. Audience, if you have any questions, doctors? Questions are question back.
Thank you so much, Dr. Lokesh and Dr. Ravi Kumar. So now let's hear it from AI expert Dr. J.B. Simhasa, who is the professor and chief mentor AI, Reva Academy for Corporate Excellence, Reva University. Dr. J.B. Simha is also the CTO of Abiva Systems. He is an AI expert and a thought leader in space. He has implemented several large-scale systems for telecom, BFSI, and manufacturing industries in business intelligence and analytics. He has been recognized as one of the top 10 most prominent data science
Breaking news.
academician in India by Analytic India magazine. His his core competency is AI, R&D, business intelligence, and analytic consulting. Over to you, Dr. JB Simha. Sir, please come on video mode and give your views on the topic learning analytics for specially abled.
Thank you, Pavitra. I would like to take this opportunity to tell something which, when I attended Dr. Kalam's 3 live sessions, he used every time I heard him telling same thing. I would like to follow that. Andaru Mahanubhavulu, Andariki Vandanamu. I feel that's the best inclusiveness that we can add. So we don't spare anybody as no, I cannot learn from them. For me, at least, AI is always the way of learning. We really don't know how anybody learns anything. We are in the nascent stages of actually looking at how AI can help. With that, I would like to go for what is that we have in the thing today. So would like to talk about introduction. I would like to talk because already the medical professionals has given their perspective and how they are treating that and what is likely to be the conditions under which we would like to bring the children so that they can become better. So after that, I would like to just get through the details, some specific details of learning in specially abled. So I do not want to call it as anything, but I would like to say they are different from us. They are different from us. Then I would like to go for learning analytics. What specifically is learning analytics? What is that we are looking at? Then we are working on some model, and I would like to discuss how exactly that model is working. Like Dr. Lokesh told very clearly, how AI can help. One of the things is video and audio modeling. Though he told it from the perspective of early detection and early intervention, we are interested in if it has happened, what do we do? How can we establish some kind of credibility or some kind of training that can help them to become better in motor skills, better in relationships, better in some kind of cognition? How can we do that? If it has happened, it's good. We can learn from that. We are looking for such kind of patterns where they are moved from one stage to the other stage for the betterment. So I will talk about that, and I will just give brief of what are the research initiatives we have at WASE. So anybody who is interested is a welcome here. Please comment, please come here and review, criticize, do everything so that we know are we in the right path or not, and the way forward, what we are planning. In fact, my early engagement or early understanding of the autism came from 2 movies. In 1988, it was called Rain Man, where Dustin Hoffman is a math genius, and his brother, he would like to get the you can see the movie, but the idea is he's a genius, but he has been treated in a hospital where he cannot have relationships because he cannot have emotions, he cannot react to the emotions. So that was one of the exposure for me to understand. Otherwise, like Dr. Ravi said earlier, we had a different opinion, but that changed my opinion. Okay, there are people like this. And then the second movie was Mercury Rising. This was a movie where an autistic child tries to detect the mercury coding system of the US security services. And it can find which is the phone number to which we had to talk. And people get scared that he's a national threat. And these two have given me, okay, there are people who are likely to be better. Though there was some, kind of subjective opinion that the people who have got autism may not be different from us. Subsequently, it has been changed. It has been changed, and one of the things that we are looking at is this is the normal brain. In fact, this is coming from the available medical and technical literature, and this is the autistic brain. The number of neuronal connections that are there in the autistic brain is different from us and is more than us. And that may be one of the reasons. In fact, we always say that they are visual learners. That may be the reason that they are sensitive to touch, they are sensitive to sound and other things. They are mostly visual learners. What I'm reading, what I'm trying to do is to understand what kind of visual stimulus, even heavy visual stimulus, they get affected. They are very sensitive. Even the commands that we would like to give, I'm reading that it has to be done through visual commands. So if such is the case, is there a possibility, are they really retarded or some kind of difference is there? current medical literature as of 2018 says 37% of the autistic children have Savant syndrome co-occurrence. So it means that they are good. They are good. In fact, it depends on how we look at, how the society looks at them. If they feel that they are not emotion, they do not have emotions, I feel they are non-judgmental. That's what Bhagavad Gita says. Sukhe dukkhe samay kutva labha labho jaya jaya. So it means that they are perfect. Whether they lose, they win, they are perfect. They are not emotionless. That depends on who is looking at it. It is purely subjective. For me, coming from the AI perspective, it feels that, yeah, that's good. That's a good tactic, thing that they have. And that is where it started. Is there something that we can do for these type of children? Like these things, what Dr. Ravi has told is already there. In fact, we wanted to concentrate only on this part because certainly this is medical domain. This is where some kind of social and parental involvement can be there. Some kind of involvement from technology can also be there. But certainly these two areas, we would like to depend on the medical fraternity. This is where we would like to support the medical fraternity to come out with some kind of technology enablers which can help the students who are called the autistic. We want to give them an ability to have some kind of support, if not fully do anything which is not possible from our side. What is possible from our side, we would like to do that. That's the intention with which we started. In fact, there are plenty of things which they would like to see. And so if we look at what are the learning problems in the disabled, in fact, it says that physical structure, they're not able to move, they rock when they stand. Is there a possibility that we can start with the gross motor skills before going to the finer motor skills? Like Dr. Lokesh said, can we look at some kind of video analytics to estimate the pose, to understand under what conditions, under what sequence it is likely to become physically unstable? Can we look at that? That's one of the areas where we are working. Reducing the auditory and visual disturbances, we would like to minimize that. In fact, in my one of my specialties where I have been taught, the more options you have, the more confused you have to take the decision. So reduce the auditory and visual disturbances. It's called Hick's law. The more options we have, we take more time to decide. Have only one option so that they will do that. And visual schedules, instead of giving any verbal schedules, the suggestion is to give the visual schedules and have very regimented work system and visual structures for a good working. So this is what has been told for teaching the specially able from the various research that has been done so far. Now, if you look at this, one of the things that we are looking at is what is being used so far in doing this. So what are the different things that have been used? The first thing that has been used are the applications. Applications, about 27% of them are applications. 10% of them are robots which are teaching the autistic children how exactly they can participate without getting irritated. In fact, I would like to say thanks, a big thanks from the bottom of my heart to the parents and the teachers and the social care workers and the doctors who are looking after such kind of children. So robots can become again emotionless. So we had to teach the robot that it has to be too sensitive with the autistic children and work for the autistic children and make sure that the children do better. So only about 10% is robots, and about 5% are alternate devices, maybe alternate communication devices, how it has to be communicated, and wearables only about 3%. Looking at that, the applications, it can be a visual application where it can teach the child to interact, to engage better. This is the focus that we are going to do probably in next 3 to 5 years. This is where we are focusing on. Now, if we look at the race model, what we have, the first of the thing we have is what is called as observation study. We are not looking at intervention because that is not our domain. Certainly, it requires the specialized professionals and medical professionals to look into that. Our focus is mostly on passive data collection. It is observational. We do not want to do any kind of thing. Just put a web camera or possibly a mobile camera and try to take the image and see what is happening with the child, how the child is learning, how the child is doing. So it is an observational study. The second thing is a multi-model approach. In fact, we are trying to go with two types of models. One type of model is to get these features. The child is happy, the child is irritated, the child is violent, the child is sleeping, the child is balanced and is walking well, the child is touching somebody. All of this we would like to get as the features from the current state-of-art models like deep learning and XYZ kind of models. Like Dr. Ravi was mentioning, medical fraternity is filled with uncertainty in decisions. It is more subjective. So I cannot put exactly how can I combine two deep learning models to come out with a decision. That is not possible with any of the machine learning models that are currently available or the deep learning models that are currently available. So one of the technologies specifically from the uncertainty handling is called as fuzzy systems, where I can combine three different specialities or specialist knowledge into one. And still I can make them agree. And that model is what we're using, and we call that model as the fuzzy frill. F stands for the federated learning. The second thing, in fact, the first is the subjectiveness of everything. The second is federated learning. The problem in federated learning, which the federated learning solves, is we do not want to share the data of the children. We do not want to know the data of the children. We just want to know the behavior and model that, and we would like to build all these models at the edge devices, not in a centralized server. We do not want to collect any of the data, but we would like to get what can be improved, how I can get multiple doctors, advice, multiple caretakers advice, which is working good for the autistic children into one model. And that model is based on what we call as fuzzy cognitive maps. I will come to that. And we are looking only at the borderline cases. We are not getting into the deep cases. We are looking at only the children who are maybe learning disabilities, speaking disability, things like that is what we are looking at, rather than socially not active and things like that, may be requiring specialist domains and things like that. And we would like to make it open source. It is copyleft. There is no copyright for this because it is the nation's property, not us. It's not anything that we would like to own. We would like to give it to the nation. It is for criticism. It is for improvement. So we would like to make sure that it's available, and anybody can work with that. And that's one of the things that we would like to get the criticism and comments from the public, from the medical domain, from the technologists. Everybody is free to comment on that. The next thing, I would like to talk about fuzzy cognitive maps. In fact, fuzzy cognitive maps, it models complex systems. Actually, for me, that's the first line of explainable AI. So instead of deep learning and other things, not that deep learning is bad, we'll be using the state-of-art deep learning and other things for feature extraction. But when we want to model a complex system, which explains, we had to go for a different technology. The second thing, which is good about the cognitive maps, is computing with words. So instead of computing with numbers, it computes with words. How can I say that this boy is slightly irritated? We never say the boy is irritated for 2.1 seconds. I never say that. We say that the boy is slightly irritated, or the boy is very violent. It's not mildly violent. It is not. So we always compute with words. We always diagnose with words. We always train with words. So fuzzy cognitive maps work with words. So we are adopting that system. And it's a hybrid system. It can learn from data. It can incorporate domain knowledge. In fact, it's impossible for any of us to introduce domain knowledge into deep learning. So I had to put all those things in the data. Then I had to make sure my model learns from that data instead of domain itself making some changes. So that is possible when we go for fuzzy cognitive maps. The fourth one, which is very important, which I was discussing earlier, was I can merge multiple models, which currently is not possible in deep learning or any other machine learning technology. So this is the model that we are adopting to learn how the students are doing better. The next thing that we are interested in is what is called as the reinforcement learning. So reinforcement learning is basically how we learn, how we learned. So how we learned, somebody did the action, my parent did the action, I observed it, and I also acted, and my parent either rewarded or punished. When it was a punishment, I stopped that. When I'm rewarded, I do it more and more. So reward and punishment in this case is totally different. So we would like to just call it as rewards. And we would like to see when the child, by the caretaker or by the doctor, when it has been told or when it has been made in a particular sequence, in a particular way, tries to do better. What was the reward? When the child was happy, when the child was having a fine motor skill demonstration, we would like to see that, and we would like to learn that. Reinforcement learning is very good in learning with that, because we start with no data. We start with just domain knowledge, and when the data comes, we go on improving that model. So that may be difficult when we go for advanced models, which others are working, but we would like to take this So we are working with combining these two, the reinforcement learning and fuzzy systems. We would like to learn a model like this. In fact, we have selected few factors based on what exactly is the concepts or the factors that we had to look into. The first of this is course characteristics. I cannot take XYZ kind of quantum learning and other stuff which will be taught at a PhD level to a kid who is not able to focus. So I must know what are the course characteristics. I must look at student engagement. I must look at content score. I must look at student support, student characteristics, environmental factors. Then I must predict or I must learn, is the user satisfied? Is knowledge construction happened in the student? Is the motor skill level improved? So we would like to list all these things. So currently we are in a position, in fact, we are doing a lot of analytics with respect to that, and everyone is welcome to raise, to work with us and give your comments, participate in the work we are doing. The way forward for us is we are doing feature extraction with rule-based machine learning and deep learning methods. We are trying to build the integrated model, which tells us what is the best way for this child. It is one-to-one recommendation, and it is learning from the field. So that will be done with what we call as fuzzy federated reinforcement learning, or fuzzy frill. And once this model is built, we would like to open this up and give this to everyone to test this and give the feedback so that we can improve it further. So this is our a small participation in this whole work, and we want all your support, and any comments, any criticism, please do. If you have any questions, please feel free. Thank you very much. Over to you, Pavitra.
Thanks a ton, Dr. J.B. Simha, sir. Let me introduce Usha Rangaraj, who is the head data science research at EXA Protocol and world's first woman triple Kaggle grandmaster. She is ranked as the top 10 data scientist in India 2020, ranked as the top 10 women data scientists by Analytics Insight magazine. She has been ranked as top 150 AI leaders and influencers by 3AI magazine. She organized the Neuro AI Neurodiversity India Summit, which is India's first ever research symposium conference in the field of neuroscience and data science. Usha is a recipient of Top 10 Women Tech Leader Award 2022 by Reva Academy for Corporate Excellence, Reva University. Miss Usha, can you please come on video mode and brief us about Kaggle Challenge on autism diagnosis?
Yeah. Hello, everyone. Am I audible? Yeah. So, can somebody confirm if my voice is audible? Yeah, thank you. We organized this Kaggle challenge for over a period of 2 months. The data set was survey responses collected from several, autistic survey responses collected from parents about several autistic people about their behavioral characteristics. And the challenge was to apply machine learning techniques to predict if the individual has got likelihood of autism or not. So this was the Kaggle competition. And we had a great response from the Kaggle community and from a lot of data science data scientists as well outside Kaggle who had just joined Kaggle to participate in this competition. We had about 130 people participating in this competition, and we had around 2,500 entries made. And the whole thing was a community competition with very less of marketing and promotion. We had a huge response, which is almost on par with some of the featured competitions out there. So this is a great achievement for us. All of this is possible because of Reva University, Ray's Corporate Center of Corporate Academy, and also Shainu ma'am, because she was the person who was spearheading the whole initiative. And autism is still considered a taboo, and not many people, many people find it very comfortable discussing autism. I have been in the autism advocacy for 4 years now, and there's general stereotypes and there's discomfort to discuss about autism and create awareness as well. Somehow people want to help, but they're not just comfortable. So there's a lot of different things which stops them from coming out and doing advocacy. But Shainu ma'am is very empathetic. We need more people like her to go, spearhead initiatives like this and support of universities like REVA. And we need other universities and other organizations to take this as an example and also do similar things. I would also like to thank Swiss Ray and TerraLogic for also sponsoring swags for these competitions. And I would like to thank all my co-speakers, neurologists Ravi Kumar sir and Lokesh sir and JB Simha sir for sharing a lot of insights on autism. And this has been a huge success for us. I do hope in the longer run we'll be organizing more such events. I'm currently dabbling on MRI segmentation data. There is a research which is coming out that MRI segmentation of MRI scans can be used to detect autism at an early age. And there's also some research from the Stanford University which is coming out. Autism can be diagnosed as early as when the child is in the mother's fetus itself. As Ravi Kumar sir said, the earlier it is diagnosed, the earlier you can do intervention. So it is very important to diagnose autism early, and there's a lot of use cases coming out using the image segmentation. And there are also other use cases which involves robotics. There's a research which says autistic kids learn well and perform better when they're trained by robots, because robots has more patience than the human counterparts. Even if it's the own mother of the child, the mother is still a human. She or he might lose patience after 30 or 40 times, but robot may not have problems repeating certain actions for more than 100 times as well. So that's something which autistic people like. They want certain things to be repeated over and over again. So there are robots like Milo, which is already out there in the market, which is around $5,000. This is out there in the US market. It's again built by a learning special ability school out there in US. But this price is a bit more expensive for the Indian market. So India needs the same kind of robots, but at an affordable price, so that Indian parents can afford it. And so this is an evolving space and a very interesting space. And I do hope everyone who's listening here will also start contributing to this social cause and make the world more inclusive. I once again thank all of them involved in this initiative. Thank you.
Shinu, we cannot hear you.
Let me know. Sorry. Yes. So thank you so much. I think we had a great insightful session from both the medical experts as well as AI experts. And as everyone is mentioning, and especially Dr. Sima, who is our chief mentor, that there is no single solution for all these things. Multiple domain specialists, technology specialists, as well as AI is one small part of it. I think the whole ecosystem, the research community is what we have to build if we want applications to come up in this space to help the final beneficiaries. And we do hope, as Dr. Simha called out, that please join our research initiatives, and we would love to bring out and further proceed with the research that which we are going through. So further, I think this is the third and the most exciting session. We are a little short of music, but we feel that we should have had drum rolls to bring all our winners. And I would request Ashok Shetty from Swiss Ray, VP Data Science Center of Excellence, and Sandeep Vijay Raghavan, Senior VP of IT Services from TerraLogic, who are our esteemed sponsors who are going to sponsor these swags. It's a Kaggle language, swags. We just say prizes, right? And I would also request, I think, Dr. Simha to come online, maybe Kinjal and Pavitra, all of you to come online so that we can actually upload for all the great initiatives. And almost some of you like Himanshu, I think he had many entries, and he was literally looking at improving his score. So Himanshu's picture is already there, but I would request Ashok to say a few words because you have been greatly helping us to put up this competition. Over to you, Ashok.
Sure. Thank you, Shinu. I hope you guys can see and hear me properly.
Yes.
Yes, the idea was basically, to collaborate with Revaverse to show, that the market that we are also not very behind when it comes to reinsurance or insurance industry. People think that banking and insurance industries are the ones that are, adopting these digital transformation a bit slowly, but that's not the case. There are some really nice tools and decks that we are using, and for that we will be needing some more, tech talent in the future. And that's why we thought of collaborating with Shinu and team, and co-sponsoring this competition. So that's pretty much about the intention. Now, as Shinu has already mentioned, I will be sharing the names of the winners. I think the first position is already announced. You all can see that in the slide. So we have Himanshu Nel. Himanshu, you're there on screen. Can you switch on your camera?
Yes, sir. Am I audible?
Yes, you are. So can you go ahead and just share your thoughts and then, share a few words with the audience, please?
Thank you, sir. Firstly, good evening to everyone. And I was really excited about this event after spending 2 months in the Kaggle competition. It's been very interesting, thrilling during the whole competition. And firstly, thanks to River University for organizing such a nice competition on Kaggle. And this is I had applied machine learning. This is basically data science competition, and applied machine learning over this. As Dr. J.B. Sima sir said that there's a more chances of improvement and doing there's a lot of scope of improvement in autism diagnosis using neural networks and reinforcement learning. So I will be really excited and happy to learn more about applying neural networks and reinforcement learning in autism diagnosis. But as per the competition, the dataset provided to us, it's a small dataset containing 800 samples for training and 200 samples for test datasets. And the most important part of this competition was the data analysis part, because there were a lot of features which are not so important and need to be dropped out. So applying data analysis, and I'm thankful to the people who help in the open source in coding section of the competitions by sharing their data analysis part. And I want to also point out some of the points from the data analysis, like the autism diagnosis. It doesn't matter that the person is from which country. Like this is one of the feature that the residence. So resident doesn't matter much. Like there was a lot of data which contains a lot of Indian people in the data set, but there are a lot of Indian people which are not suffering from autism. So ethnicity and residence, these are a few of the features we need to drop out, and some features which are important were the results and the 8 and scores. And this is the things which I use as a training set. And for the final algorithm parts, I used most of the algorithms, like rich classifier, extractive classifier, logistic regressions, and the boosting techniques, because boosting technique is one of the most famous techniques used in Kaggle competitions. So my final algorithm part was ensembling logistic regression and extractive classifier. So this is my approach to all the competition, and happy to be part of this competition. Thank you.
Yeah, Himanshu, thank you for sharing the formula that others will again be copying. Thanks for sharing the formula for winning. Thank you, and congratulations once again.
Thank you, sir.
Thank you. Now, without further ado, I'm going to be, sharing the names of the second winner, and it's not really a winner; it's a winners, right? So it's a team. There are two people, part of the team. So let me take their names. It's Pratik Hariram, and then Prakhar Jain. Guys, can you please switch on your video and share a few words? Thanks. Pratik, I think you're talking, but we are not able to hear you. No, not yet. No. Prakhar, do you want to go first?
I think Pratik, you are speaking on mute, I think.
Prakhar, we can hear you. You can go ahead first.
Yeah, Prakhar, you can go ahead first.
So yeah, hi everyone. Yeah, this is Prakhar and my teammate is Pratik Hariram. So we thank you for all conducting this competition, and thank you Deva and all the sponsors for conducting this competition. So the competition was, first of all, the competition was quite interesting, and yeah, we faced a lot of obstacles while doing the doing the competition. So yeah, some of the obstacles I can relate now is the data was imbalanced. So it's a real life data, and another is uh, another is handling outliers for the country and everything. So yeah, that's what the major analysis and major problems we faced. Then the model building processes, I think Pratik, are you available?
I think I just saw him popping in. I think we are having some issues, audio issues with Pratik. Pratik, we can't hear you still. Yeah, now we can. Yes, please go ahead.
Yes. Sorry about the issue. Yes. The thing, thank you for Reva Academy and the panelists who are present over here for giving us the opportunity to the autism thing. My first interaction with the autism is through a series. You may hear about The Good Doctor. There is a series based out of autism. That is the thing I came to hear about the autism thing. I will just stick with the technical thing right now. We have used various classification models, and we have also used the auto ML approaches to get the highest prediction score. But the thing is, we just stick with the random forest for getting the highest score. That is the algorithm we have used to get the highest score over that. This is the approach we have used to get it. Thank you all for giving us this opportunity.
Thank you.
Thank you, Pratik.
Thank you.
Thank you so much.
And congratulations. Congratulations once again. Now I'll hand the session over to Sandeep, who will be announcing the next winners.
Sandeep, happy to have you here again. This is Senior VP of TerraLogic, who has been helping us to build some of the capabilities, especially in cloud and cybersecurity programs. He has been a through and through supporter for all our initiatives. Thank you so much, Sandeep. If you want to say a few words.
Thank you, Shinu. So it has always been a privilege being associated with Reva and Race, and this is definitely a noble cause. I'd like to congratulate all the winners for this particular Kaggle competition. I'll not take much of a time. I'll straight away start introducing the next winners. So, Jaya Prakash, may I have you on the video?
Jaya Prakash, are you there?
Jaya Prakash, can you hear us?
Okay.
Right.
Yeah, I think we can announce the next speaker, who she is also incidentally not there.
Okay, we'll announce the winner for sure. So, Suchi Kumar.
Yeah, Suchi is. Yeah, Suchi is also not there, but she is sending her sincere gratitude to all of us. And she says she would like to thank the organizers and researchers for this wonderful work we have been doing in this space. It was an interesting topic to work, and I would like to extend my support further on this initiative. Yeah.
The next winner is Arnav Raina.
Arnav, are you there? Arnav is on speaker. You can speak up, Arnav.
I would like to thank all of the expert speakers for making us more aware about autism and how it actually, how we can use machine learning to solve such a real world problem. And I would also like to thank Reva Academy for presenting us with such an approachable machine learning data set on the real world problem of autism. As one myself who has just recently stepped into machine learning, this competition actually gave me an amazing experience about how it feels to solve something which is real world using machine learning. Trying out different algorithms and optimizations was an enjoying experience. I actually, 2 months ago, when I found out that LG Light GVM, Light Boost, was so much popular, I thought, yeah, let me just try it. But when I tried it, its accuracy was not that much good. So I fell back to XGBoost, and then I started optimizing it using Optuna framework. So this was my toolbox that I actually used to solve this competition. In the end, I would just say that I learned more and impressed old. Thank you.
Thank you so much, Arnav. Okay, so thanks everyone, Ashok and Sandeep. Jayaprakash, are you online? Jayaprakash, are you online? So maybe we are losing. If you're online, please come. No, we can't hear you. I think how much our technology glitches are still there, blaringly affecting all of us in this virtual world. Okay, so thank you so much, all our sponsors, and we have a few questions. So I would request both doctors as well as AI doctors, both to address some of these questions. Okay, so the first question that we would want to take up is towards, I think most of it is coming from, the first question maybe to the doctors. Neurodiversity means learning disabilities. I think this is one of the things that which we had discussed, that no differentially abled. So this maybe Dr. Ravi and Dr. Lokesh could answer this. Neurodiversity means, is it including learning disabilities?
Yeah. Okay. Since very wide, neurodiversity does not mean something is abnormal. For example, somebody is very good in mathematics, somebody is not very good in, say, for example, reading skills. So there's a diversity, but just because a child is not good in something, it does not mean disability. Each person is bestowed with some skills which are better than others. For example, people who are here, I think you guys are very good in technology, artificial intelligence, numberings, data science, whereas we are not very good at it. So we are diverse. That's all I can communicate as very simple way.
Very nice.
Yeah.
I hope that is clear. It's not neurodiversity means basically we are diverse. Simple example is Indians. We are very diverse population, starting from somebody in Northeast to South India, or even the West Punjabis. We are different physique, different skills. So just diverse. That is what diversity means. That's all.
Okay. Yeah, thanks. I think it is all in a spectrum. It is a range. that where do we stand, each of us, at various imperfections that we have. Like Dr. Simha again mentioned that let us consider all of us as human beings with different gradations and capabilities. Great. Another set of questions are for AI experts. Dr. Simha, if you could start saying that first question is that how do you convert video and audio data into something useful in this case?
Yeah, basically, we would like to go with the abstraction. For example, if I'm looking at the video analytics, I'm looking at the child and I would like to detect what kind of facial expression is manifested in the child's face. What exactly it is, because it may be a supervised kind of learning, and I would like to detect, is the child smiling? Is the child smiling on its own, or is it smiling because as a reaction for something it has seen? Is the child working properly? That is another analytics, which is nothing but the pose estimation or kinematics, right? We would like to take these features. Now, let us say that I have a problem where I'm looking at the motor skills of the child, and I would like to detect the child is standing properly. If the child is standing properly, I have the normal child and the autistic child. If both of them are walking, can I use a single class classifier to identify there is some deviation with the autistic child? And if I cannot differentiate both of them, certainly I pass the Turing test. I do not want to call the child as a autistic child, but the child has learned it. Because for me, categorizing looks very odd, though doctors may disagree. I agree with the doctors. AI will not agree because we don't know. We start with the method that we don't know. The idea is abstract the visual features. What are the visual features that we can extract? The first of the feature is he is walking properly. He is walking properly is extremely abstract and extremely subjective. How can we convert that? So I would like to say that normally I would like to measure, first I would like to get the features of a child moving 3 meters forward and backward. When the child moves with only a tilt of 5 degrees to either side, the child is normal. That may be my definition. Doctors may say, no, you change it. Then I may be taking a normal child and I would like to say, I observed this. The normal child also, the angle will be about 5 degrees. So I take this as the normal. And if I can extract that feature, I would like to say that after 200 attempts, the child is able to walk properly. So is it 200? Is it 195? Is it 205? I don't know. But certainly there is some number which we would like to see, and it may be different for each of the child. And these two models, the first model which detects the features, which will be using most of the state-of-the-art neural networks and things like that. The second one, which handles the subjectivity of defining what is good, what is somewhat good, what is very good. Those things we will be taking from computing with words. We are combining these two models. The next question.
So interaction with the rules can still be in fact our studies.
We would like to talk to the parents. We would like to talk to the medical fraternity, the caregivers and other people, whether this is really active, this is really working or not. We do not want to put anything, okay, computer did something, AI did something, take it. That is not the intention. Intention is to critically evaluate and cut it into pieces so that if it really comes out well, everybody will accept it. That is the idea. The idea is not to take the data, build some model and then give it.
That's not the idea. Idea is to see. Basically, we start with the rules, because when we start some learning, especially reinforcement, the data may not be there, and I have to use the rules. My deep learning network will not allow me to use the rules. I have to go and I have to depend on fuzzy kind of thing, which is okay with the subjective evaluation, not very crisp logic. It is not if it is less than 45. What is 45? 45.1, 45.2, or 44.9? I'm not clear. If it is something around 45, is computing with words. We would like to use that and introduce those rules in my reinforcement learning model. And that model will give some kind of insight into how the child is taught. Because I will accept, I don't know how to teach that child. I have not seen how to teach such a kind of child. Like Usha said, I may get irritated, but I know my limitation. Like she said, the system may be so patient that it may give, okay, I will learn. You do 100 times, I will be happy. Right? I will not complain. That is what we would like to teach and instruct in my rule base, which may not be possible for me to configure in a neural network. So if you look at it, we are doing two things. The first thing will be feature extraction from the deep neural networks. The second one will be, using these features to arrive at child is improving or neutral. And if it is not improving, if it is decelerating, what may be the reason? What is the sequence in which the child got agitated, the child got moved out, how it happened? That is a feedback. In fact, if it happens in a period of 5 minutes, in the first minutes itself, if I can predict the child is likely to be like this, that can be an excavation or it can be a early warning for the tutor. That is what we are looking at. Such kind of things is what we would like to do.
Thank you, Prof. I think it's a elaborate discussion is required because of the scarcity of time. We will take one last question addressed to the doctors. It is further to the question asked or the suggestion given by Usha on fetal detection at when the baby is in the womb itself. Are there specific types of cells which can be detected during those early stages, which can lead to such detection? Dr. Ravi or Dr. Lokesh?
I mean, it's studies are there. One thing we need to, highlight the fact that it's not only anything in neurology for that matter, right? The diagnosis is not like how we diagnose a cardiac condition or a liver condition or a kidney condition, where you have a defined biochemical parameters, where you have a proper range and value. Whereas when it comes to the behavioral parameters, we follow a criteria. When you say criteria, it's all about lots of subjectivity is involved there, right? Trying to make it objective, trying to look at, for example, there are so many things described on MRI in autistic children, right? But still, there is nothing consensus that it has to go two-way around. That means I describe these are the features that we see in autistic. Now, all these features that we take that can be diagnostic when a new sample comes, right? So these are the things which are working on. Maybe in the future, we hope that we get some kind of this kind of an accurate biochemical or structural markers that are very specific to autism. Now, extending to that, for all the people who are in this AI community, would like to tell you that when as a doctor or as a human, when we are looking at anything, we are multiple dimensions. We're looking at it from multiple dimensions. So, as Dr. Davis Sima said, unless until we combine several models and each model tries to look at this particular problem at one particular dimension, only then we can realize the actual AI aspect of it. As of now, the best of best models, we are at at a screening level, or maybe just a level 4 or level 5. Level 1 is the one where the model what we build can take in all the information and then analyze it and come out with the outputs, not only in terms of diagnosis as well as treatment. But at this point of time, we are at that level of level 4 or level 5 where we just can screen. But we need to build model by model, divide the problem into smaller pieces, gain expertise, and then we can just move forward. And I think that's the right direction in which Reva University, this program is working on, and we would like to be happily be a part of it and take this forward. So the whole intention is to help the child, help the parents. So that's the entire motto, right? Thank you.
Thank you, sir.
That's a great assurance. Thank you so much. I know it could be a 10-year project or more that requires multiple use cases to actually build that data and open it to the community. And as Dr. Simha mentioned, that we are looking at, say, code left kind of or copyright, copy left kind of an attitude, that so that everyone could refer. And as Usha mentioned, can we build a cheaper, efficient robots for every parent, right? So I think these are all grand ambitions that we can further advance this research. So we have almost come to the conclusion of this kind of a 1 hour, little more extended. I would slowly little introduce our university. I know it is towards the end, but as you are aware, we are in Bangalore. We are just a thrown away from Master CMI, which is again in the Hebal, and I'm hoping that people who are looking at autistic support system, Dr. Ravi Kumar and Dr. Lokesh is going to help you further, because we know that the audience also include parents who are requiring some of these support systems. If you are looking at building a research environment, then we are open in terms of the university. We have an excellent campus. I know Dr. Lokesh has visited us. It's a beautiful campus. The kind of environment that we are building is place like, say, Ashok incidentally is doing a doctoral program, Dr. Simha and 50 plus mentors who are building the research capabilities. And this division, which we call it as Reva Academy for Corporate Excellence, have been doing this emerging technologies programs, not just programs, but very focused on certain research areas and consulting, where we are looking at developing products out of our training. And we are so glad that all of you could connect on this single reason or this noble cause, that building something towards autistic community. And in terms of program and the ecosystem, that what you see here is we have mid and senior range of experienced professionals going through various programs. It could be data science, AI, cybersecurity, cloud, techno-functional, leadership kind of programs, so that we have not siloed our learning. It's all domain kind of agnostic, multi-technology specialized programs is what we run here. And we are so fortunate that we got amazing support from the industry. So those who are looking at our programs, do visit our website, which is race.reva.edu.in, where you will see transformational journey our participants have gone through our program. We boast some of the highest ROI programs in the market, and the programs range from short-term to long-term programs in masters and customized programs. We also do some product development, commercial product development, as well as social cause product development. We also do customized training programs in these areas, which we would want all of you to please look at our website and understand. And if you think that some of these are of your interest, please reach out to us, and we would be happy to build that ecosystem. It's not that we cannot solve all these big challenges, but certain right steps with the right mentors, right medical experts, and AI specialists like Usha, who has been championing so well, and she's so young, but the kind of activities that she's doing around, we are really fortunate to have the right guidance that helps us in fast tracking the process. Otherwise, it is very difficult for us to actually know what to prioritize, how to prioritize our energy and resources. So we are hoping that this dialogue will continue. We will create an ecosystem which will bring out certain action plans with certain timelines to help this community. So please, we look forward to your continued support in further events around this area called learning disabilities or learning abilities. We'll not call it as, I think any learning is an ability, so we'll call it as learning abilities, and provide better quality of life to the people who are affected. So with that, thank you so much, all of you. Thanks again our sponsors, Ashok, Sandeep, and Infosys actually, and everyone here. We have a big team here who is supporting us, who has been, the whole race team is here, signing off from all of us, and especially to the doctors, amazing support, and it has been wonderful having you. Please do visit us and continue the dialogue. Thank you. Good night. Thank you.
Thank you, Dr. Simha. Thank you, Dr. Usha. Thank you.
Thank you.
Everybody. Thank you.
Thank you. Bye.